welcome back. In this video, we're going to look more at measures of center and spread and also when the appropriate time is to use each. The median is a natural statistic to choose when you want to describe the center, right? Especially when you have a skewed distribution or if it has any outliers. And remember, the reason to do that is because we say that the median is not sensitive to outliers. If you have an outlier, it's not going to affect the median because the median is just the middle number, right? So it's not affected. But if we have a skewed distribution and there's outliers and we use the mean or the average to describe the center, the average is affected by outliers. Okay, one single outlier can either pull the average up or lower it and make it distorted. So we have to be careful when we use the mean, but the mean is actually very useful. And statisticians actually prefer to use the mean or the average rather than the median because there's a lot of tools that we can use with the means, but not the medians. Okay, and we're going to see that as we get into inferential statistics in the later part of the book. For now, a simple rule of thumb is to use the median to report the center for a numerical data set that shows strong skewness or outliers primarily on one side. If the data are unimodal and somewhat symmetric, then the mean and median should be approximately the same or equal to each other, and either would be okay to summarize the center of the data. Okay, so remember, mean and median are used for measures of center. There are two means that we're going to look at. One is a population mean, which is symbolized using the Greek letter mu. It looks like a cursive U and an M, kind of. And then the other is the sample mean, or it's a Y with a bar over it. And you really could use any letter. So X with a bar, X bar, Y bar. Those are the sample mean. So to give you an example, right, population mean would be if I wanted to find the average height of all males in the world, okay, every single male existing, that would be mu. But if I take random samples of males in various places and find their heights, since they're a sample, the average would be a sample average, and that would be Y bar. Okay, so that is the difference. If you think back to how you calculate a mean or an average, you add up all the numbers and then you divide by the total number of numbers. So Y bar, your sample average, is just the total divided by the sample size. Okay, in statistics, we have a symbol for total or sum. It's the Greek symbol sigma. And anytime you see a sigma, it just means sum, so add. And it's saying add all of the values, the y's, and divide by the number of numbers, which we just call the sample size. So that's what n is. Okay, so that's an easy formula, right? But how do we know whether to use the mean or the median? Both summarize the center of a distribution, but in different but useful ways, okay? So the median, remember, is less influenced, it should be a D, by skewness or outliers than the mean. So therefore, the median is better as a measure of center for summarizing skewed distributions. Okay. The mean, on the other hand, as we said, is sensitive and pays attention to each value in the data, which makes it more appropriate for overall summaries that need to take all of the data into account. So any distributions that have outliers, you would not want to use the mean to describe the center because the outliers could affect it. The mean is sensitive to extreme values. So when that happens, it's best to use the mean when there are no outliers or your distribution is roughly symmetric. Okay, let's talk about measures of spread. So remember the IQR and standard deviation are measures of spread, how spread out the data is, and also the range, right? So the interquartile range is always a reasonable measure of spread. But the problem is, like the range, it only uses two values. So it just uses the quartiles, right? So interquartile range is a reasonable measure of spread, but it only uses two quartiles. And if you remember, it was quartile 1 and quartile 3, right? So it ignores much of the information about how individual values vary. Same thing with the range. It uses your extreme values like the max and the min. So you also don't see how the values vary, in relation to the mean. So we have another measure of spread that is very useful, and it takes into account each value and its distance from the mean. It's called the standard deviation. And what we look at is the distance each value is from the mean. Okay, we call the distances, we call those the deviations. Like the mean, the standard deviation is most appropriate for symmetric data. So anytime you want to report the mean for your measure of center, you would also report the standard deviation for your measure of spread, okay? Anytime you have, and that's for symmetric distributions that are unimodal, anytime you have any distributions with extreme outliers or they're skewed, you would want to use the median for your measure of center, and you would use the IQR, the interquartile range, for your measure of spread, okay? All right, if you could, please pause the video and we're gonna work out how to find the standard deviation, and then I'll show you in your calculators how you can do that. Let's take some class data and find the standard deviation the long way so you can determine, how it actually is calculated. I think it's important to understand how we get standard deviation, okay? And then we're gonna let the calculator in the future just do all the hard work for us. So how long does it take you to commute to this campus? We're going to calculate the mean commute time in minutes for students and the standard deviation of the commute times for students. We'll need to take a sample. So since we don't really have a sample of numbers, I'm going to use data that I got from a class in a previous semester that I wrote down, okay? So what I did was I took the standard deviation formula and I broke it down. So I took it apart and put it into this table. So these are the steps that you're going to use to find the standard deviation. So the first thing we need are the values, the data values, and then these are the numbers. And it's in minutes. So this is how many minutes it took 5 students to get to the downtown campus, which is where I'm located, okay? The first thing I need to find, if you'll recall, is my sample average. That's what Y bar is, or sample mean. Okay, how do I find an average? I add up the values and I divide by the number of values in the set. So if I add these, I get 20 plus 20, which is 40, plus 25, that's 65, plus 15 is 80. So the sum of all of these is 80. And then I'm going to divide by 5 because there's 5 numbers. So that tells me that my average is 16. That means it would typically take a student 16 minutes to get to campus, okay? My next step in finding the standard deviation, since I'm interested in how far each value is from the average, now that I have the average, I'm going to take each value and I'm going to subtract the average. And I end up with the following. And if you see here, the problem is we have some numbers that are negative, and that's a problem because distance is not negative. So we, can solve that problem. How could I get rid of the negative? I could square everything. So that's what it's telling me to do in this next column. It's saying take this and now square all of that. That'll get rid of the negatives. But, in math, there's always a catch. It's about balance. So if I square something, you can do that, but you have to undo it at the end. So now I'm going to square all those numbers. And when you square a negative, you always get a positive. Negative 11 to the second power is 121. Negative 1 to the second power is 1. 9 to the second is 81. 4 to the second power is 16. And again, negative 1 squared is 1. Okay. Do you remember what sigma tells you to do? Sigma is add. So it's saying add these, add what you just found. So if I add up those values there, you get 220. Okay, now I'm going to take this, and it says divide by n minus 1. Well, n is your sample size, right? And there's 5 numbers there. So n is 5. I'm going to divide by 1 less than that. And the reason we do that in statistics is because the sample standard deviation, which is what we are trying to find, is what's called an unbiased estimator. It gives us an accurate prediction or reading of what the population standard deviation would be. Okay, 220 divided by 4 is 55. And just when you think you're finished, you're not quite yet. Remember when we squared everything to get rid of the negatives? Well, now I have to undo it. And how do you undo a square? You square root it. So I'm going to take the square root now, okay? And we're going to take the square root of 55. And when you do that, so if you're using the graphing calculator, the square root button is, let's see, 3 buttons below the green button, but it's in blue, so you have to hit the blue. So you hit second x squared, and then we would just type in 55 and hit enter. And let's round to 2 places, so 7.42. Okay, so this is 7.42 minutes. How do I know it's minutes? Because this is also in minutes. Standard deviation takes the same units that your data does. So how exactly would we interpret it? Well, first of all, 7.42 minutes compared to the mean, that's a pretty small number. That means there's a low standard deviation, which means there's less variability and more consistency in the numbers. And there is. I mean, they're really not that far from each other if you were to line them up. 5, 15, 20, 25, they're really not that far away. So their standard deviation should not be large, okay? If I had numbers that were really far away from each other, like 5 and then maybe 25, 60, 85, 110, that's going to make my standard deviation much larger, okay? If the numbers were even closer, like 5, 10, 15, 15, 15, you would find that the standard deviation would be less because they're a lot closer on average to the mean, okay? So what does this actually mean, the 7.42 minutes? Well, my average was 16 minutes. That means that's the typical commute time for students to get to downtown campus. What does the 7.42 minutes mean? It basically means that your commute time will differ from the mean by an average of 7.42 minutes. So some values will be 7.42 minutes lower than the average, and some will be about 7.42 minutes higher than the average. Okay, so your commute time will differ from the mean by an average of 7.42 minutes. And we also said that this is a low standard deviation. And that means we have less variability and more consistency. With the numbers. Okay, I want to point out this number right here, the 55. That number right there has a special name. It's when we add up the squared deviations and find their average in column 5. We call the result the variance. Okay, so here's our variance. And the variance is s squared. Okay, So how does it relate to standard deviation? Well, standard deviation is just the square root of the variance, right? Here was my variance, and I took the square root of it, and I got my standard deviation. So this represents s squared, your variance, and that is your standard deviation s, and that's your sample standard deviation. Okay, so how do we exactly find this standard deviation? We found the sample standard deviation by taking our numbers and subtracting the mean, right? Squaring it. Then we added all of those squared deviations. We divided by the sample size minus 1, and then we take the square root. Okay, if you want to find the population standard deviation, that's the Greek symbol sigma, but it's lowercase sigma. Okay, so here's sample standard deviation, here's population. The only difference is instead of dividing by n minus 1, we divide by n, because n is the population. So in other words, instead of dividing by 4 here, we would have divided by 5, because there were 5 numbers to begin with. Okay, and as we said, the variance is just the variance is actually the standard deviation squared. So the standard deviation is the square root of the variance. Okay, so another way you can look at it is the variance is just equal to whatever the standard deviation is squared. Okay. So populations, remember we use Greek symbols. We denote it using the Greek symbol sigma. That's your population standard deviation. So the population variance would be sigma squared. Okay, let's see how to find the standard deviation on our calculator. So I'm going to go in, and if you'll recall, to enter a list of numbers, you're just going to click stat and enter.
When the place smells delicious, but
An ad here that I need to wait and get through. And I apologize for this. Okay, that's what happens when we use free stuff sometimes. So I'm going to go up to my list and again highlight it and hit clear. And then I'm just going to hit the down arrow and I'm going to type in my 5 numbers. It was 5, 15, 25, 20, and 15. Okay, hit enter. Now to calculate, if you remember, I'm just going to go back to stat and I'm going to go to calc. So I'm going to hit the right arrow and it's one variable, commute time, right? It's a quantitative variable. And all I have to do now is hit enter. And there's my summary statistics. And as you can see, if you look at SX, right, that is my sample standard deviation that I found, 7.42. Underneath it, if you wanted to find the population standard deviation, remember you would divide by 5 instead of dividing by 4, and you would have gotten 6.63. Okay, so it's that easy to find. All right. So let's summarize here really quick. When we have skewed distributions, do you remember what measure of center and spread we use? If you said the median and IQR, good job. We use the median and interquartile range for skewed distributions. And then, of course, when we have unimodal and roughly symmetric distributions, we use the mean and the standard deviation. Okay, so they go together. So think of it like this. Here's a heart. I know I'm a bad artist. You've got the median and the IQR always together. And then we've got the mean and the standard deviation always together, always and forever. Okay, these guys are for skewed distributions or distributions that have outliers. These, the mean and standard deviation, are for symmetric distributions that are also unimodal, where there's no outliers. And remember, it's not wrong to use the median and IQR if the distribution's symmetric, because if it is symmetric, the mean and median will be equal to each other approximately. But we just prefer to use the mean and standard deviation because they're more useful, and there's more tools that we can use in statistics using the mean and the standard deviation. Okay, so what I would like you to do now is pause and read the problem, and then try this problem on your own. When you're ready to unpause and do the problem, you can follow along with me. So Nakiria owned a Nissan Maxima for 8 years. Being a statistician, she recorded the car's fuel efficiency in miles per gallon each time she filled the tank. She wanted to know what fuel efficiency to expect as ordinary for her car. Knowing this, she was able to predict when she'd need to fill the tank again and to notice if the fuel efficiency suddenly got worse, which could be a sign of trouble. How would you describe the distribution of fuel efficiency for Nakiria's car? Remember to think, show, tell. Okay, and I provided the histogram and the summary statistics for you. Remember, when you need to describe the distribution, what things do you need to talk about? You need to talk about the shape, the center, the spread, and any outliers that are there. Okay, so give me a second, and I'm gonna have this so that I can type this out because I think it'll just be easier for you all. I apologize for the screen going sideways there. Okay, so when I'm thinking, it's basically like, okay, what is this problem asking me for? What do I gotta look for here? Okay, so what do I wanna do? Well, I wanna summarize the distribution of Nissan Maxima fuel efficiency. Okay. The data is given in miles per gallon, right? As I can see in the summary statistics and also in the problem. And fuel efficiency is quantitative, right? So I want to make sure I check the quantitative data condition, make sure that it's appropriate to use a histogram, and also to summarize using, mean, median, and IQR and standard deviation, etc. So the data is given in miles per gallon, and fuel efficiency is quantitative. Okay, so again, I'm checking the quantitative data condition. Okay, so that's the think, right? I know what I got to do. I have my information there. So the show is already done for us, right? So let me label this. This is the think. The show we did. That's see the histogram and summary statistics. And then the tell. Okay, so when I look at this, what story do I want to tell? And I want to talk about the shape, the center, the spread, and outliers, and make it so my audience can understand it, right? And use correct statistical vocabulary. So looking at this, what are some things we notice? Well, I can definitely see that it is unimodal. There's one peak there, okay? I can see that it's roughly symmetric. If I was to fold, it's approximately the same on both sides. Remember, real life data is never going to be perfectly symmetric. I would also say that maybe there's a lower outlier, but we would probably have to investigate that further. Since it's symmetric, what measure of center and spread should I use? It would be the mean and the standard deviation, okay? So, which they provided both of them for us, right? So my job now is just to talk about this, like to write this out. Okay, so I would say something like the distribution of mileage is unimodal and approximately or even roughly symmetric. Again, it's not perfect symmetric, right? With a mean of 22.4 miles per gallon. What does that mean? It means that Nikiria can typically expect to get about 24 miles to the gallon when she drives the car, okay? That's what average means, typical. There is a low outlier that should be investigated further. Like, why did she only get about 14 miles to the gallon on that day? Was she stuck in traffic? What's going on? Was there a maintenance problem? So there's a low outlier that should be investigated, but it doesn't really influence the mean that much, right? Because most of those other values would typically be close to, if you look at the histogram, the values are close to the mean. So, since it's symmetric too, but doesn't influence the mean much. Okay, what else? So I mentioned the mean, so I want to mention the standard deviation. The standard deviation suggests what? That you can expect the car's fuel economy to differ from the mean by an average of about 2.45 miles per gallon, which is small. So that means that, typically the miles per gallon or fuel efficiency that the car gets, it doesn't vary much from, each time she uses it. So suggests that from tank full to tank full, Nikiria can expect the car's fuel economy to differ from the mean by an average of about 2.45 miles per gallon. Okay? And I apologize for my cat screaming in the background because she's hungry. But anyway, I hope you all have a great rest of your day. If you have any questions with this chapter, please let me know. That is the conclusion of chapter 3, which is summarizing and displaying quantitative data. Enjoy the rest of your day.